Today we're going to talk about how this adaptation has taken place in the UK. The UK government's industrial strategy has placed AI and the data generation in the construction sector as one of the four grand challenges that will enable UK to be a leader in the industries of the future. The recent Indian government's mandate for an infrastructure revolution towards smarter cities is aligned with a similar objective. So today we're going to discuss about the top technologies that are changing this sector. One of the biggest disruptors in the way we think, plan, execute, and manage a project has been by utilizing building information modeling and artificial intelligence. My background is as an urban designer and architect. My name is Manisha Bhartia, and I have worked both in the UK and in India. The company I work for in BDP is one of the global leaders in BIM Level 2. One of our first projects in India in 2011 was a new campus for IIT. This was done on a BIM model. Essentially what this was a model where that enabled us to design better, and all the information that we needed as designers was put on it. The UK is now moving towards BIM Level 2, which is what we're going to talk about to some extent today, and that's a more collaborative model of working. We have in our office a lot of designers who are very experienced in BIM Level 2, but none of the work that they do is in the Indian space, and that's a catch. So as we talk today, I think one of the things we should remember is that as an industry in India, what do we need to do to change as an industry to keep up with the digital trends worldwide. The speakers we have here today are from a range of organizations in the UK: policy enablers, architects and engineers, clients and innovators, all presenting a very unique view on the digitization of the sector. They will take us through UK's digital journey, and hopefully we can pick up some lessons along the way. I will invite each speaker to talk for 5 minutes, after which I will start off the question answer session and attempt to contextualize this for the Indian market. I'd like to introduce our first speaker, Adam Matthews. Adam is the head of international at the Centre of Digital Build Britain. CDDB is a key enabler in the UK government's strategy for advancing the infrastructure sector through digital technologies. Adam, can I request you to kick off the session and set the stage?
Okay, thank you very much, Manisha. Well, good afternoon, everybody. It's a pleasure to be here today. I'll bring it down a little bit. Okay, too much enthusiasm after lunch. Sorry about that. So what I'll be talking about, to pick up on Manisha's point around this as a national policy and a national change for the construction sector. We've got many different sectors here. You can see we've got Fintech, Agritech, we've got motor technology and so on. But construction is actually one of the least digitalized sectors of all. So there's a tremendous opportunity to improve the performance of the sector, but also the performance of the built environment. So I'm going to talk through that from a national perspective in the UK in terms of what we did. Okay, I knew that would happen. The technology is letting us, there we go. So we recognise that in the UK and globally, there's a tremendous opportunity in construction to get better value for money, because construction is largely a very analogue sector, very traditional sector, and so there's a great opportunity to improve the performance of the built environment, but also the performance of the construction sector. So what did we do? In the UK, we set out a construction strategy. Now what this is about is government taking a leadership role, working with industry to help define and shape a 5-year, 10-year strategy for construction to help it digitalise, to help it introduce technology. You may have seen a little bit earlier, the video that we were showing was representing building information modelling. Now, building information modelling is the construction sector's moment for digitalisation. Manufacturing has gone through it, aerospace has gone through it, biotech has gone through all of this modernisation. Now it's the turn for construction. What we did, very simply, is set a goal as government to say that all centrally procured projects will be required on this collaborative use of building information modelling that Manisha referred to. We call it BIM Level 2. We set a date. We said that by 2016, all centrally procured projects, that's hospitals, schools, roads and railways and so on, would require to be delivered using building information modelling. And we set a goal for industry. Not only did we set a goal, we set a cost target, which was 15% savings over that 5-year period. So here you see we had ministerial support, we had our central cabinet office say this is what we want to achieve. Why do we want to do this? 2 things we wanted to do. First of all, make savings, 15% savings on public spending, but also as a goal to create a digital construction sector. And that's what all of our speakers are going to talk about today, is what's the value of having a digital construction sector. We had a roadmap, we had an implementation plan for how we were going to do this with industry. We set a really clear team in place to help drive this, because this wasn't just about changing contracts, this wasn't just about doing things individually with technology. This required a change of thinking from a client perspective, and we're actually going to hear a little bit about that today as well. So we need to put in place standards, we need to put in place new procurement definitions, and we had a team that was formed to drive this across the whole of central procurement for the UK. We changed client procurement from analog to digital. What do I mean by that? First of all, the way we procure as clients today ends up with a pretty inefficient result. We procure just analog drawings, PDFs, schematics, plans, and so on. What we changed was made that requirement digital. And by making it digital, we said we want to have digital delivery of information at key stages through the project lifecycle and the asset lifecycle as well, to inform decision making. This was a really central point of our BIM mandate in the UK. What did it deliver? £3 billion roughly in terms of savings over a 3-year period for our construction strategy, of which BIM was a major pillar for it. Now, this is the really interesting bit, is that we said we wanted to deliver more infrastructure for the same amount of money. You can see in the bottom right corner there, 5 + 2 = 7. That means that for every 5 schools we're buying, in old money terms, we're getting 2 schools for free. So we're getting 7 schools for the price of 5. This was actually one of our ministerial promises to industry when we started this program 6-7 years ago. So it's clearly been really valuable. What we've done is 2 additional things around standards. One is to work nationally, and you're going to hear a little bit about this from our speakers, to create procurement definitions and standards, technical standards and skills definitions for the whole country. And secondly, we've worked with international bodies, in particular with ISO and the European normalization body, to define this at an international scale so that we can encourage and help trade. That's the reason we're here today at the Futuretech Festival, is to think about how we can create trade. What this does is create a common language so that across different countries we can understand each other in this digital construction way. And that's really important, to be able to trade and share our competencies. Now, the next stage we did was recognise we don't want to be on our own. We don't want to be on our own at the end of a pier. We want to be very collaborative, and so we work very hard with other governments around the world, in Asia and in Latin America and across Europe. Still very friendly with all of our European partners. I should stress that at the moment, obviously. Working together very collaboratively to agree and harmonise those standards so we can have one common definition around not only Europe but around the world. And this has been a fantastic project of collaboration. We've signed agreements with 20 countries in Europe, about 5 countries in Latin America, a similar number in Asia as well. Government-to-government agreements to align on policy, on strategy, and on those common definitions that we spoke of. Thank you very much. Thank you for your time. Thank you.
Thank you, Adam.
Okay.
I imagine to build buildings of the future of the nature that you're describing, we need the best skills and material. I'd like to ask Rufus Logan, who is the commercial director of BRE India. BRE is the world's leading building science center. Rufus will tell us about his organization and the role they play in delivering this strategy along with CDDM.
Thank you very much. Yes, my name is Rufus Logan. I'm from the Building Research Establishment, based in London, near Glasgow, and in South Wales, and in numerous places around the world. What is Building Research Establishment? Well, we are an international multidisciplinary building science organisation with a mission to improve buildings and infrastructure through research, knowledge generation, and their application. And we are an independent organisation, being previously part of the UK government. We're now owned by the BRE Trust, which is the largest charity specifically dedicated to research and education in the built environment. And we've been a charitable trust for the last 22 years. We use cutting-edge research to develop a range of products, services and standards and qualifications that are used around the world to bring about a positive change to the built environment. So what do we offer? We're BRE. We develop knowledge through our research with research partners. So we offer expert advice and research programs. We undertake world-leading quality work in standards and testings, everything covering from fire safety, security, through to building science, materials, off-site construction. And through this knowledge we gain through our research and programs of testing and development projects we undertake, we've developed a lot of insight into how buildings perform across their life and how they perform in terms of energy sustainability. And that gives us a lot of data and information from which we can learn from as a construction industry. And that learning we try and translate into education and training programs, and we've established a BRE Academy that's providing both e-learning and classroom learning. So the key point for me is BRE is we're at the heart of construction in the UK in all aspects of it, and the UK government, working with people such as ourselves, asked the question, is it finally time for change? And Adam touched on this about Digital Built Britain and the programs that come from that. And the answer is absolutely. The infrastructure pipeline in the UK is very large and it's extensive over the next 5 to 8 years. There's some £650 billion worth of infrastructure ongoing. The UK government has produced an industrial strategy that looks at this as a deal for the construction sector. And within that strategy, the customers it's reflecting the customers are becoming more demanding, and as I'm sure we all are. We want to have our assets built for 33% less cost. We want a 50% reduction in time to complete, and we need to reduce our greenhouse gas emissions by 50%. And furthermore, we want to look at reducing our trade gap by 50% within the construction sector, which is a big reason for the Futuretech Festival today as well. And these are driven by both the customers and our legislative requirements. And how can the construction meet these if over the history of the construction process it hasn't really changed, productivity has not increased over the last 20 years or so. So the UK industrial strategy sets out an ambition to have a better performing buildings, lower energy use of buildings, better jobs for people working in the construction industry, better value for taxpayers who often are paying for these buildings, and a globally competitive sector. And as Adam points out first, we have digital techniques, off-site manufacturing, and whole life asset performance are the three strategic themes for the UK construction industry. And my final point here is that just 2 weeks ago it was announced that the UK government's sector deal has provided £72 million for a programme to develop a core innovation hub project. That's been secured by the Transforming Construction Alliance, which is made up of the Manufacturing Technology Centre based in Coventry, the Building Research Establishment based in Watford and elsewhere, and University of Cambridge Centre for Digital Built Britain, which is Adam here today. These three organisations came together over a period of almost 2 years to develop the programme that we're setting out to do over the next 3.5, 4 years, literally to transform construction. And how are we going to do that? Well, the focus of the work is on digital and off-site manufacturing. And what we're going to set out to do is advance new knowledge and approaches to construction, totally new knowledge, develop new jobs and skill sets required to deliver those new systems, and build the supply chain, which is absolutely critical in construction, around digital-based knowledge. And the outcome will be a higher quality, cost-effective buildings that perform better, are more comfortable and effective to live and work in, are safer, healthier, and use less energy. And we're going to do that with the MTC, which is an Innovation Manufacturing Technology Centre and partnership, the Centre for Digital Built Britain, and BRE. And just to say, this is only part of a larger programme, which is £170 million worth of transforming construction. So I hope people who want to engage with us today and look at the ways of doing digitally could do so. We look forward to speaking to you about this programme. Thank you.
Thank you, Rufus. You're talking about transforming construction. Sorry. Yeah. I'd like to invite Alan Waha, our next panelist. Alan is a global head of Bureau Happel's BIM sector, and that's one of the many hats he wears. Alan, could you tell us more about the transformative performance of BIM?
Let's see if the tech works. Yes, it does. So I'm an aeronautical engineer, and this is my 17th year in India, actually. So this is the story of what happens when tech meets engineering. So let me introduce you the engineering firm and then the tech. The gentleman rightly introduced the fact that we are an industry that is the least digitized in the world, bar forestry, and that really we want to do much better. We need to build 39 metro systems in India, and they can't keep on coming in late. They can't keep on taking 5 years when 2 should be enough. So Bureau Happel, very briefly, it's the kind of company that is set very tough challenges, engineering challenges by really ambitious client. An Olympic stadium that needs to become a football stadium, incredibly complex shape, train station, and at the far end, a recently opened City of Dream Macau hotel, Morpheus, and we're very lucky that Paolo is going to describe how this was designed and built in a minute. So when you are a global design community and you are asked to design these kind of things, what happens is you start thinking about technology and across all scales. So we design buildings, we design cities, and buildings live in cities, and cities impacts what you're building. So we cover every scale. And the first thing that happened about 4 years ago is that Bureau Happel committed to go all in. You remember BIM Level 2? Bureau Happel said from now on, everything will be digital. The consequence of that is that you can design these kind of buildings. We topped out that building 2 weeks ago in Dubai. It also means that we get awards all over the world now for being the best implementation at BIM, which is nice, but so what? We had buildings before. So what I'd like to explain is what do we try to do with technology. So this is our Mumbai office. We design tall buildings. We design stadia. We design master plans. We have about 180 people in Mumbai working in India. What does what we call prop tech, build tech, design tech look like? Well, the first thing is, because everything is digital, you'll want to think about how you leverage that technology. This technology stopped functioning. Here we go. You'll adopt the technology. You'll go on a journey. You'll adopt, like music went digital. But then after that, you said, hey, now that music is digital, I can put it in an iPod, and then actually I can sell it online. And I invented iTunes. Well, this industry is going to do the same. So what does leverage look like, and what does transform look like? Well, if you want to design a stadium, an arena, the first thing you're going to do is, why do I design it manually? Why can't I get the computer to help me? Because that's what I want to create, a model. Now I'm going to create a computer that responds to the human and automatically generate the design. That's what you're going to do. And then from that design, you're going to produce everything you need. All the checks, all the documents, everything is going to come out of this. So that if you change your mind, in about 8.5 minutes, you're going to redesign the whole building. I was just talking to Paolo. We were calculating the construction sequence of Morpheus 3 years ago, and it used to take 4 engineers about 3.5 months. We now calculate it in 20 minutes because the construction firm asked us to recalculate it. the whole thing recalculates automatically, because that's what you would do, wouldn't you, once it's digital? You wouldn't be focused on the fact that it's MP3 music. You'd think about what do you do now that it's digital. Now the second thing that happens, and is that at the heart of your engine is now you have BIM models, but you have programmers, you have AI thinkers, you have machine learning experts, right? So that's what's happened to your firm. So then they're going to say, but what do I do with this tech? Because actually what I wanted is better performance buildings. So for example, if you look at the stadium and you think, okay, now I've generated it automatically, what's happening inside? Well, you're going to apply machine learning to try to figure out what's happening inside. You're going to see who's standing, who's sitting. You're going to look at what's the phase of play and the interaction between the phase of play and what's happening in the crowd. And then you're going to apply your automatic design generation to understand whether the stadium can, for example, generate a home advantage. So that's, in very broad terms, the topic that I hope we're going to discuss.
Thank you. That was very interesting. And Paolo follows. After Paolo is with Zaha Hadid. And Paolo, I hope you will be talking about the building in Macau that Alan just mentioned.
Yes, I will. Okay, good afternoon, everyone, and thank you for joining us today. Thank you to DIT for inviting us, and also to Alain for having introduced today our building in Macau. The aim today would be to show you what we did with BIM recently. So how basically our company works with BIM, and what's our contribution to the entire engine. Because it's not, of course, an engine that can be built, let's say, only, I mean, this level of complexity at least has been built by many different contributions coming from different companies. So Bureau Apple gave his own contribution, and Zaha Architects build up his part in terms of design definition of the different components of the building. But just let me give you a quick introduction to our company. So we are an architecture practice working all over the world. Our core business used to be Europe. Now we shifted toward Asia and China, and we expanded in Australia, Middle East, and North America, where we also open our new branches. We work at all scales and in all sectors, so big residential development or big master plans as well. This is a set of twin towers in Australia for a mixed-use development. Just would like to give you two keywords to better understand the architecture that we like to design for our clients and for our customers. The two keywords are landmark and experience. So our building are offering a sort of let's say catalyst effect in the wide regeneration area where cities are trying to implement their programs and their ambitions. So basically our company grew up during the 80s and the 90s. This is the period of the urban marketing when cities were investing huge amount of resources in big regeneration programs, and architecture and architects were called to give their contribution through buildings that could have not only symbolically represented the regeneration, but also work as attractors for the entire urban compound. We do not only do landmarks, but we also give experiences. So we give additional values through our buildings. It's not a matter of putting together a brief and try to make the client happy and the customer satisfied of the services they will receive within the building. But visiting our building is supposed to be an experience on its own. So visiting the galleries of the Maxi Museum in Rome, or entering in our conference call in the Azerbaijan Cultural Center, or again entering into the Morpheus Hotel in Macau, which we recently completed, is an experience on its own. Before entering into the Macau building, I would quickly tell you that our specific contribution to the BEAM model is through parametric design. So what we do in our company is that we develop engines which could really produce and generate the components in the space. So we do not simply describe the architectural object that we want to build, but we basically generate them in the space by taking into consideration all the parameters and the tolerances and the inputs which are coming from structural engineers, mechanical engineers, design constraints. So on the top left, you see a painting Zaha did about 20 years ago, I would say, which is again the Maxi Museum. And bottom right, you see one of our preliminary study on a master plan, which has been done with a full parametric engine. So I think there is a thread between those two images here, because on the top left, you can see how Zaha's vision of the space wasn't really linked to pure Euclidean object and volumes displayed in the space, but was more a matter of introducing deformation, transformation, and continuous adaptation of the volumes to the urban fabrics. And this is exactly what you do when you enter into a parametric design. So you basically take the variables out from the object, you analyze the variables through algorithms, and you change the shape in the space continuously and softly. And that's what you get at the end. So it's a 20 years work around this kind of research, and this has been plugged into a BEAM concept kind of activity, which is the one that we then finally implemented in the Macau's building. So now I will go quickly through those slides because I think that we just have a few minutes, but this is the Maxi in Rome, just to give you the feeling of the work, and those are our parametric adaptation of urban landscapes. So you can see the link between the two objects. Again, this going back in time, this is the first project Zaha was awarded for in Hong Kong, which is the peak. Again, it has been done with the same criteria of the slow transformation, the smooth transformation of the objects in the space. And let's enter into Macau's building now. So I'm not going too much technical in that, but I'd like to invite you for a visit of the building. So the idea behind the building is that basically this is the 5th tower into an hotel casino park. The 5th tower, the idea was that he was supposed to be the main portal to enter into the casino area. And at the same time, we did want to close the loop, which is the green loop of the shopping mall at the ground floor, not with a kind of a cul-de-sac going up and down in a single building towers, but we did want to split the building in two, basically creating a promenade that could have somehow closed the horizontal loop. So I will go quickly through. So atrium, then we go up through the panoramic lift, we reach the mezzanine level, then we enter into the first bridge, and the bridge which is spanning between the cores. This is the plan, and then again the Chinese restaurant. And then we reach finally the top of the building with the swimming pool. And then we go down again, we enter into the second level where we have the lounge, where guests can do their breakfast, and then we land again down into the lobby, where music and interaction is always playing a key role. So now I'm just scrolling quickly those images. As you can see, the facade goes from a fully flat condition to a completely twisted condition. So this transformation has been obtained by using parametric design. So we define the condition of the object at the beginning in the flat typical condition, and then through the parametric transformation of the object, we lead it through the complex part of the building, and we close basically and we extract all the details and all the components, and we bake everything from there. So all the nodes, all the members have been baked from the engine that we developed. Of course, the level of complexity is then higher, so it's a kind of a fractalic structure. So you find the same level of complexity when you enter into the cladding. This has been engineered by the contractors, and they took our model and they developed with the same system all the secondary components, which has also been extracted to support the panel. So the BIM model has been built from 5 different locations all around the world, 24 hours work worldwide. And that's what we finally obtained. And those are the images from the site, construction site, and that's the end. Thank you.
Thank you, Paolo. I think it's quite impossible to cover a building as complex as this in 5 minutes, and I think we'll come back to this in questions. Our next panelist, Malcolm Taylor, is the head of technical information at Crossrail. Crossrail is one of the largest infrastructure rail projects in the UK. Over to you.
Good afternoon. It's a real pleasure to be here. I think I have a similar sort of problem in 7 minutes to get through a talk about £15 billion project. But very quickly, what I'd like to try and do is give you some examples about what digitization, going digital, and BIM means in practice in a live project, and show you examples of what that actually looks like. The Crossrail, very quickly, it's a very large project that's going to, in information terms, provide this £15 billion railway, giving 10% increase in rail passengers in London, 200 million journeys a year. It looks like nothing you've seen on London underground stations before, very large, very big caverns. And if you see the widths of the platforms and have a look at that slide, you can see that's a typical station platform, Liverpool Street existing, and what the new Crossrail platforms look like. Lengths of several football pitches underneath London. Huge amounts of equipment that need to go in to actually create these railways, particularly underground. And this project, the budget and the schedule were fixed 10 years ago, and we're still reasonably close to target on all of that if you take the bigger picture. It's a very complex project, over 100 contracts that all have to fit together and work. It's a program of projects, and this is where BIM and management of information is so absolutely critical. The scale, again, if you stand back and look at the impact of construction in London, the interfaces, both with the real estate above and the environment. This shows you a typical station at Liverpool Street that connects actually 2 existing tube stations. That's a lot of excavation and engineering underneath London. Managing information, it's all about trusting your data. This is at Tottenham Court Road. Crossrail is the yellow tunnel there you can see at Tottenham Court Road station. It's a 7-metre diameter tunnel boring machine, almost the height of that dome over to our right there, and it's got to go through that gap. It's 83 centimetres above the red northern line and about 50 centimetres shy of that blue escalator shaft. You've got to have some very good information to know exactly what you're doing there and trust it implicitly. If we couldn't have done that, we'd have had to take the tunnel boring machine about 10 metres lower, and that would have added £1 billion to the project. So being able to make those engineering decisions is about trusting your data and your information. So what does that all mean? In Crossrail, for us, going digital is about defining our world, and not losing the slides, actually. It's about deciding and recognizing that you're actually building 2 railways, a digital and a physical. You define exactly what you want in terms of information at the end. You create a way of capturing and working with that information, and you're trying to use technology, particularly in the BIM environment, to manage it. In an old world, everybody used to have a copy of everything, and in a BIM world, you have a common data environment within all your information, your models, your documentation, everything, all features in one area that everybody uses. And again, in an old world, what used to happen with all these particular activities is that you used to create a big IT department and lots of people trying to join lots of different specialist software applications. And you end up, although your objective is to build a railway, you end up building a huge IT department to support that. in a Crossrail world with a common data environment, what you're actually trying to do is get rid of all those software applications and undertake those activities using workflows in simple databases. For us, 3 databases joined together, and all of those different activities are done using workflows in those sets of databases. What that means in our world is that common data environment, that single source of truth, means everybody is collaborating, everybody's working together, and what's more, for us, in terms of a business case, it's saving us over 120 million pounds over the life of the project because of the savings in software, the efficiencies with people. It absolutely shows you that going BIM and following that sort of approach of a common data environment makes sense. Very quickly, just to show you some examples of what we do. 3D modeling's been around for 20, 25 years, but as you saw from Paolo, with parametric modelling, it's the way you use it and the way in which you manage space between different disciplines. You can take that 3D model into construction, into 4D and 5D as we've done, where the model is then used for actually managing progress, monitoring the installation here in terms of the fit out of stations, agreeing on site using tablets what's been installed and making your efficiencies of, in fact, even with an as-built model, so much better. And again, another example here of going digital is here where when you're building, for example, the tunnels, there's a lot of equipment that needs to be attached to the tunnel walls. But the tunnel walls, there's a lot of rebar, there are joints to avoid. So here is another simple case. And what we did was do a LiDAR point cloud survey of the entire existing tunnel as is. You could then work out exactly where those joints are, exactly where the rebar is, so the contractor then could build a special purpose gantry to go through and know exactly where to drill and where not to drill. So one person could then manage this machine, increase productivity by a factor of 5, improved health and safety, no end. So that's all about taking that model and being smart in the way you can apply technology to your world. So again, sorry, just back there, the issue about off-site manufacturing and bringing into your site precast units to build your construction by using that model. The world of activity on site is all carried out in one database, collecting all those types of information together. It means because all your information is one place, you can report on it very easily. And it also means that you can slice that information up in particular ways and give it to here 4 different sets of users, but the information is coming from that one source. So finally, really, all of the one of the key things is you manage data as you would, and the quality of data as you would say the quality of concrete and steel. You check it as you go, and it's important to consider the quality of data that you collect because it's going to be used for 100, 120 years. So finally, there's a significant amount of information on the background of Crossrail on our Learning Legacy website, and next year when we finish creating Crossrail, it'll be named after this lady. So that's my talk. Thank you very much.
Thank you, Malcolm. In delivering large infrastructure projects, there are a number of risks that you've outlined and schedule overruns. Dave Amratia from Nplan will talk to us about artificial intelligence and how their innovative platform could be a solution.
Hi everyone. My name is Dev. I'm the co-founder and chief executive of a little company in London called Nplan. What I'm about to talk to you about is the future of planning. Planning is the essence of understanding time and how you're going to execute your project. So when we all complain that our construction projects are late, well, they're late according to a plan. So if you don't get your plan right, you're going to keep getting late. And we've been thinking about what does the future of this look like. So what I'm going to talk to you today about is what does the future of planning, what does that entail? What was once a very boring subject is now suddenly getting very exciting. So I spent many years of my life on construction assets, and I've spent a couple of years as well in policy terms with the UK government. But more importantly, this is the problem we face. Construction projects are inherently complex. There are hundreds of work fronts that open up. And this is what we use to plan or manage these projects. This is the Gantt chart. This is the plan. This is how we think of how long something should take and what sequence we're going to do it in. This is a universal standard. It was invented in the it became a lot more pronounced in the 1950s, and we have not innovated past this in many years. We now use building information modeling and the fourth dimension of the building information model to visualize this. But remember, a human has to figure out how long and what sequence everything should go into. And how do you know that? Well, you have to have experience. So what we said was, can we combine the world's experience and bring that to the fingertips of the user or to the construction companies? So what we do is we've learned how projects execute. We taught an algorithm to learn from historical projects so it can try and predict how a future project might work out. I said that these projects are inherently complex, and the epitome of complexity in Europe is Crossrail. Crossrail is the largest construction project going on in Europe right now. Its Gantt chart, its schedule, has 1.2 million activities on it. And that's a number that, no matter how smart you are, no human will understand that. What we did was we took Crossrail schedule into our system. We compared it against 300,000 other projects and schedules from around the world, $500 billion worth of capital projects. And the algorithm was functionally able to detect patterns. It said, hey, I see that you're going to do this. And based on that, I can, based on my quote-unquote experience as an algorithm, I can detect that this is where you're going to go wrong next. So what it does is it creates a really interesting dynamic. All of a sudden, an algorithm now is able to provide the human, who historically for generations has been the most knowledgeable expert in the room, with an algorithmic expertise. This algorithmic expertise can say where it thinks the end date of the project will be. Might not always be good news. It'll tell you where it thinks things will go wrong. I sometimes struggle to call it an it, but let's go with the it is doing all this work. And it doesn't get bored, meaning it continuously learns. The more schedules it sees, the smarter it gets, and it's a perfect learning cycle. We've developed all of the code in-house. We hold 6 global patents. We built the entire system using our team of 15 engineers. These are some of the faces that are behind it. AI, big surprise, is not built by itself. It's built using people. And our team is made up of a few more people that are a bit upset that their faces are not on here. But the team is now made up of 11 PhDs in neuroscience to mathematics to machine learning. So a really simple thing, you put your schedule in, you ask the system, and it'll tell you what it thinks of your project. I'll skip through these quickly. And because it does it for every single task, it does it for every single project, doesn't matter how big it is, whether it's Crossrail or a commercial building, it can see how hundreds of projects would perform at a time. So for large organizations that are executing hundreds of projects, you would need to see what to focus on and how much effort to put into each project. And this is a cold eye version of sensing that. So the really interesting thing now is because an algorithm is stepping into the picture, it changes the dynamics of contracting. In a typical model, the client will say, I want it done faster, and the contractor says, no, it's going to take twice as long. And there's this battle between the client and the contractor as to what does it actually take to get something done. In this case, NPlan doesn't take sides. We're not trying to favor the contractor or the client. We'll simply give a sense of realism. Unfortunately, NPlan is not about building bigger, better, faster, cheaper projects. This is just about helping everyone understand what realistic looks like. And realism is a really important thing, especially in this industry when you can't call out when someone is telling you a lie or is telling you against the truth. What that generates is a shared understanding of risk. It gives you certainty of where your projects are going to go, and it changes the game in competitiveness. All of a sudden, your contractors to the client have no way of misleading a client down a pathway into contracting. And that generates competition, increases the game, and functionally, everyone is now learning from each other's data. The system, I said, has learned from 300,000 schedules. It's the largest single collection of project schedules in the world. That's collective knowledge. It's anonymous, it's held securely, it's held safely, and no single person can go back and check where it came from. And that in itself is a really interesting dynamic. A few of the people that we started working with initially, High Speed 2 is the next mega project in Europe, and we'll be helping them figure out where schedule risks sit. Thank you.
Thanks, Dave. Our last panelist, Nimish Gupta, is the Managing Director for South Asia for the Royal Institute of Chartered Surveyors.
Right, technology gives up on us the moment we try to get the AV around. I'm sure most of you would have felt in your video conferences, sometimes your voice is going, your videos are not coming, or vice versa. Or sometimes you deliberately avoid that. Right, let me talk about it while it is coming out. So I still have time, so thankfully you have given me more time now. When we talk about industrialization, we are now looking at Industry 4.0, which is all about being wired, being connected, real-time responses, making sure that these real-time responses are making us restless, making sure that these restless responses are changing the business models. And whenever we are talking about changing the business models, we talk about is going to create a whole set of disruption in the entire planning process. What you saw in digitization, whether it was design processes using BIM, prefabrication technology, which basically uses BIM and CNC models to make sure that you get into a robotic production. So I've been fortunately part of an organization, Langrok, which was basically dealing with a lot of automation in the year 2005, 2006, when people were not aware of how to take the BIM to the next steps. And we were talking about design for manufacture and assembly. So today, while we are talking about moving from traditional to modern construction, that requires a lot of leadership, technology to get into it. Buildings and location, which if the video comes over finally, you'll get to see that. But buildings and locations may not be the key factors at all. How these buildings function, how do they build society, how do they build community of the future are of importance and tremendous value to each one of us. How data will work for us, how AI can support every development which we are looking at, that is going to define how the built environment sector is going to go. So from a situation of interpreting a data or interpretation to adoption, we are now looking at disruption. And I'm sure I will be very happy to take questions later on what is happening in India at the moment, to give you a picture of what is happening over here with respect to adoption of technology and where the gaps are. But I can actually give you in a nutshell, whatever we are talking about over here, there's a huge gap which exists in the development which are happening in UK and what is being done in India, which basically gives a lot of opportunities for companies who are at the front end bleeding edge of technology to make sure that they make a huge business case to come and develop industry over here in India. Are we on yet? Right, Manisha, maybe till the time video comes up, we can actually start with the questions.
Yeah, I think that's a good idea. What we'll do is that we'll have a series of questions and then we'll have the video and questions about India.
We can go with the video because that, yeah.
You have worked a lot on the industry side, India side also. And also this question is to Alain, since both of you have worked extensively here in India. So
could we, if we have time, could we have the last 5-7 minutes for questions for the audience? Yeah?
Yeah.
Yeah? Okay.
Sorry about that, I'll pick that up for sure.
Yeah. All right, thanks. So, and we'll come to that because that's a really important question to contextualize what the UK has done and the market in India. But one of the questions I want to ask is the role of the client. And Malcolm, this one's for you. A big part of BIM, a success of BIM, is client leadership. And so could you tell us a bit more about the role the client may play and...
Sure.
Yeah.
No, I understand completely. Well, it's interesting. Most of technologies like what we see are not actually created by clients normally. They're created by designers, contractors, consultants, and it's the client actually creates the environment within which all this can come together. And if you don't get control of it, or if you create a sort of arid, aggressive climate, you may not get the sort of collaboration that you need and you want when you're working together. And particularly in a BIM world where you have some quite complex projects, you really need people to collaborate well. So as a client, you need to be able to, first of all, really understand the benefits of these technologies, not just understand them as point solutions, but how you're going to benefit from using these technologies, and then create the contractual environment for which these things can work. So clients play an absolutely critical role in being able to benefit what these technologies can do. So you've got to get your head around it. You've got to actually recognise, as with all contracts and construction, there are risks. So it's part of a risk management approach. And actually, as I think you and smart use of information, it's all about making better decisions, which can actually reduce your risks. So it's understanding what you're doing is so critical.
Thank you. And Adam, this one's for you. One of the common perceptions is that BIM is only appropriate for very large-scale projects. You talked about the UK government strategy on BIM adoption across. And what advice would you have for smaller firms, smaller clients, smaller projects? Is there a cost benefit to adopting BIM and so on?
When we first started our program, we were beginning to set a target that actually this would apply only to projects above £50 million and above. Then we said actually we need to bring that level down because the construction sector is made up of a lot of very small projects. So we said, well, actually let's make it £5 million and above. And then we realised that actually this technique, this digitalisation that we're talking about, adds value to all projects. So why would we set a limit? So that was a view from the policy side, that we shouldn't have any limits for the projects that we introduce BIM onto. And secondly, we've seen, and there's plenty of evidence for this if you want to go to the BIM Alliance, which is the UK BIM Alliance website. There are lots of projects there from very small architects that have used BIM on housing extensions and school projects of less than £5 million. So yeah.
Alan, you talked about the transformative power of BIM. What value do you see automation? What value? I mean, in an engineering project that you show, there's a lot of tasks that get repetitive. So, what value has that brought about in the projects you've done?
Right, that's a great question. So, I think as engineers or as designers, we want to spend time thinking about the problem, not doing repetitive manual tasks. So, radical automation, I think, is the way we free our time to actually do what we paid to do, which is to think and to understand the problem. I think that's fundamental. And second, I think as an information quality point of view, that stadium I showed is 600,000 BIM objects, each with 40 attributes, so that's 2.4 million data points. I don't want to be checking them with a red pen. But Paolo, maybe you have a view about how automation and generative design.
So can you hear me? Yeah. Okay, so we are a multi-platform company. So basically we are open to use any software that could somehow help expressing our vision and to build up the space that we want to obtain. So we are always open for collaboration whenever we have the opportunity, also entering into the detail of the software and the way it works and the way it could be implemented. So we do research. We have a code department within our company which is doing computational design since 10 years now. they have been quite silent for a while. And now we are taking on board the product of the work, and in parallel with the achievement that they have brought into our projects, we also keep on hiring new generations, so basically young talented architects which have this kind of know-how, so they can enter into the kind of engine that you've seen on the screen before, and they can take the input from our, let's say, more senior team and transform it all the way through the buildings and let the visions that we want to get becomes true.
Thanks, Paolo. I think on this, this one's for Rufus. It's BRE is about training, and in a way is the new world for the young, talented architect, as Paolo says, or how can we have the older generation included in this process?
Yeah, thank you. Yes, the training we undertake is actually professional training with people who are in industry, and I think it's really important that the collaboration here is the theme for this, so that we are working with the leaders of digital applications to develop training modules that fit with it. Now, very often you'd be needed to train to be an accredited person or an approved person, such as BIM, a BIM approved person. But that would have to be done to a standard, to the BIM standards. So people have to understand what those standards are. Are they global standards? Are they adopted by India? Do the companies working in this space know about these standards? So there's a lot of knowledge transfer first, and just general awareness that first needs to be done, I think, before we land with what one would call training. So there's that collaborative process is the first step along the way to do that.
I've been told we're running out of time, so I'm going to try and open. Do we have time for one or two questions? Yeah? Do you want to, Nimish, do you want to take this gentleman's question first?
Yeah, for sure. Yes, can you repeat the question?
So this question is to Nimish and Alain, because you have worked extensively in the Indian context. What are the challenges that you have faced in implementing BIM? Because BIM is all good all around the world, but here when it comes to India's soil and working with government and other agencies, changing the mindset is one of the most important aspects of implementing BIM. Have you faced these challenges while working here in India? What are the other challenges that you faced? How we can overcome them?
I think both me and Alan share the same thing. BIM cannot be a standalone platform. It has to be a philosophy of life. In my previous stint in 2007, we could actually do a BIM project, completely BIM-enabled project, but that was a prerogative of my own. I had my own set of architects, structural engineers, MEP engineers, who got significantly benefited out of BIM, and I could do the job 30% slicker than I was doing it in 2D. And I was producing master plans, I was producing digital collaterals, I was producing drawing production in probably 30% of the exact time, which otherwise I'll probably do it in 2D for that matter. Having said that, the challenges actually remain, as you rightly put it, in the mindset. And where is the mindset change has to happen? It has to start from the sponsor, from the client itself. If he's willing to invest in understanding the value of basically implementation of BIM and technology into his project, things will happen very smoothly. If you have clients like Crossrail, who basically encourage people to go into DFMA, to go into technology-enabled thing, I'm sure more and more contractors would love to get themselves involved also, because that's the future. You can't avoid future anymore. You can't basically be an ostrich buried with your head buried in the sand, right? The world is not changing. World is changing. It is getting disrupted every day. I'm not sure, Alan, if you have to add to this, please.
Yeah, I would just say that I'm hugely enthusiastic about India, because there's so much. It's such a huge market. But on a note, the client sets up an ecosystem, and so it's easier to make an ecosystem for one project, however large, than a whole subcontinent. But sometimes, we talk about disruption. Let's celebrate also how we could help each other. There are unique market conditions in India where we can translate what has been learned. The sixth fastest unicorn in the world, so that's a billion-dollar company pre-IPO. The sixth one, any sector, is a company that's 50% Indian in this sector. It's called Catera CAF Infra, and it's proposing to build cities and houses at scale. And it's building 40 hospitals in an industrialized way on a digital platform. So yes, 40 hospitals at the scale of India, maybe that's not very big. And we have to create a whole country ecosystem. But we have champions here, and I think by augmenting them, we've got a huge opportunity together.
Okay, thank you everyone. I think one of the key messages is that digital transformation is not just about technology, but it's about a change in mindset, a fundamental shift in culture and the way we think about it. And thank you to the audience and all the panelists.